Imagine you're running a company with terabytes of data flowing in every day. Customer transactions, website clicks, IoT sensor data, videos, images, machine learning models. Where do you store all of it? For years, companies had to choose between two imperfect options, a data warehouse or a data lake. One was reliable but expensive. The other was cheap but messy. Then came a new architecture that combines the best of both worlds, the data lakehouse. In this video, you'll learn what a data lakehouse is, why companies like Databricks built it, how it differs from data lakes and data warehouses, why Delta Lake is the technology behind it, and why it's become the modern standard for analytics and AI. Let's get started. To understand the lakehouse, we first need to look at how data architectures evolved. Step 1. Data warehouse. Traditionally, businesses stored structured data inside data warehouses. These systems were designed for SQL queries and business intelligence dashboards. They offered fast querying, strong governance, ACID transactions, high reliability, but they also had limitations. They were expensive, they relied on proprietary storage formats, and they struggled with unstructured data like videos, images, documents, and logs. As organizations generated increasingly diverse data, warehouses alone were no longer enough. To solve this, companies introduced data lakes. Instead of forcing data into tables first, a data lake stores everything in its raw format. Structured data, semi-structured data, unstructured data, all in low-cost cloud storage. This flexibility made data lakes ideal for big data, machine learning, data science, but they introduced a new problem. Without governance, transactions, or quality controls, data lakes often became disorganized. People even started calling them data swamps. Because neither solution was perfect, companies ended up using both. Raw data landed in the data lake. Then important business data was copied into the data warehouse. This became known as the two-tier architecture. While functional, it created several challenges. First, the same data existed twice. Second, organizations had to maintain two different systems. Third, every time new data arrived, ETL pipelines had to move it from one system to another. This increased infrastructure costs, engineering effort, security complexity, and perhaps the biggest issue. By the time data reached the warehouse, it was often already outdated. For businesses relying on real-time insights, stale data became a serious problem. This is where the data lakehouse comes in. A data lakehouse combines the flexibility and low cost of a data lake with the reliability and governance of a data warehouse. Instead of maintaining two systems, everything lives in one platform. That means one copy of your data, one storage layer, one governance model, one platform for analytics, business intelligence, machine learning, and AI. This dramatically simplifies the entire data ecosystem. Teams no longer waste time moving data between systems. Everyone works from the same trusted source. So how is all of this possible? The answer is Delta Lake. Delta Lake is an open-source storage layer that sits on top of cloud object storage. Think of it as an intelligent metadata layer. Instead of only storing files, it also tracks table versions, file changes, transactions, schema history. Because of this metadata, Delta Lake enables ACID transactions, time travel, schema enforcement, schema evolution, data validation, reliable streaming. Without Delta Lake, cloud storage would simply be a collection of files. Delta transforms those files into reliable database tables. That's why it's considered the foundation of the Databricks Lakehouse. So what makes a lakehouse different? Let's look at its core capabilities. Open storage. A lakehouse stores data using open file formats like Parquet. Because these formats are open, many tools can read them directly. Whether you're using Spark, Pandas, TensorFlow, or PyTorch, everyone can access the same data. ACID transactions. Traditional data lakes don't guarantee reliable writes. Two jobs writing at the same time could corrupt your data. A lakehouse solves this using ACID transactions. This ensures every update is atomic, consistent, isolated, durable, exactly like a traditional database. Schema enforcement. Data quality matters. If someone accidentally writes incorrect data into a table, the lakehouse can reject it. This prevents bad data from silently entering production. Schema evolution. At the same time, businesses evolve. New columns appear. Existing schemas change. Instead of breaking pipelines, the lakehouse allows controlled schema evolution while maintaining governance. Time travel. One of the most impressive features is time travel. Imagine someone accidentally deletes millions of records. Instead of restoring from backups, you simply query yesterday's version of the table. Or last week's, or version number 37. This makes debugging, auditing, and recovery dramatically easier. Streaming and batch together. Traditionally, streaming systems required separate infrastructure like Kafka. Modern lakehouses support both streaming and batch workloads on the same platform. This reduces operational complexity while enabling near real-time analytics. Organizations are increasingly adopting lakehouses because they eliminate many of the problems of older architectures. With a lakehouse, you get one source of truth, lower infrastructure costs, fewer ETL pipelines, better governance, built-in reliability, machine learning and buy on the same data, open file formats, real-time analytics, simpler architecture. Instead of constantly moving data between systems, everyone works directly from the same platform. Let's quickly recap. A data warehouse provides fast SQL queries and strong governance but is expensive and less flexible. A data lake offers low-cost storage for any type of data but lacks reliability and governance. A data lakehouse combines the strengths of both. Using technologies like Delta Lake, organizations can store all their data in one place while gaining ACID transactions, schema enforcement, time travel, high-performance SQL, streaming support, and machine learning capabilities. That's why the Lakehouse has become the modern architecture for analytics and AI. If you're learning Databricks, Spark, or preparing for data engineering interviews, understanding the Lakehouse architecture is essential because it's now at the core of modern data platforms. Thanks for watching, and I'll see you in the next video.